Hello students, I welcome you all to the amazing platform of AriserTalent. I'm Arpita Sharma, your maths teacher. Today we are going to study the complete summary of our chapter, which is quadratic equation. Okay students, so in all these lectures we have studied it thoroughly, but in this particular lecture we are going to have a quick revision of all the concepts, okay, the theory part, right? Okay, so this was the very chapter of ours, quadratic equation. Now, the basic concept we have gone through, which every algebraic polynomial, and we have discussed this polynomial, chapter 2 of our syllabus, right, of second degree. Second degree is called as quadratic polynomial. So, when the polynomial is having the second degree, that will be known as quadratic polynomial, and when we put equals to sign and then we put a 0 in the RHS, that will become an equation, and that polynomial expression will then become to the quadratic equation. Okay, for example, these all are what? Here we are having 2 degrees, here we are having second degree, here we are having second degree, and again the highest degree of this is 2. So if the highest degree is 2, this is a quadratic polynomial, right? You know it, right? Okay, then the next point is general form. The general form is what? Ax square plus bx plus c. Okay, you, me, we all know this very well, that this is the basic form of quadratic polynomial where x is not equals to 0. Okay, and this is our chapter quadratic equation, right? Okay, now a, b, c are real numbers and a is not, sorry, it's written x here, a is not equals to 0, right? A is not equals to 0, that means this term should have some value over there. Okay, now for particular quadratic polynomial, the values of a, b, c constant, and for this reason a, b and c are called as real constant. What? Real constant. A, B, C are known as real constant. For example, quadratic polynomial 3x square minus 5x plus 8, this 3, this minus 5 and 8 will be known as the real constant. Okay, and x will be the variable. Value of the quadratic polynomial. What will be the value of the quadratic polynomial? Okay, so if we'll put x equals to something, like if I'll be putting x equals to alpha, then the value of this will become a alpha square plus b alpha plus c. Okay, then that will be the value of this quadratic polynomial. If I'll put x equals to 1, that will become a plus b plus c, right? Then that will be what? The value of this polynomial, quadratic polynomial. At x equals to 5, this will be simply 25a square plus 5a plus c. 5a, not 5a corrected, it's b here, 5b plus c. Okay, so this is what we call the value of a quadratic polynomial. We are just revising polynomial concept here because the same concept will be applying for the quadratic equations also. Okay, zeros of quadratic polynomial. Just ignore this example. What is the zero of quadratic polynomial? The particular value at which the value of quadratic polynomial becomes 0 is known as the zeros of the quadratic polynomial. Okay, if like in this equation, if I am putting the value x equals to 2 and the value comes as 0, then that will be, let's suppose it's, let's find out this value, that will become 0. So this is how we solve this. Okay, you can remind it. 16, so 2m equals to 16, m equals to 8. Okay, so the value of m is 8. That means this equation is basically 6x square minus 8x plus 4. Now, the 0 of this polynomial is what? 2, because at 2 equals to x, the value of this polynomial will be what? Simply 2 to the 4 is 12 minus 16 plus 4. Now that is 16 minus 16, that will reduce this as 0. So this value of this polynomial expansion at x equals to 2 is equals to 0. Then that means x equals to 2 is what? 0 of this polynomial. Okay, we may have more than one polynomial. Okay. Now quadratic equation and its roots. What are the roots? Okay, so the value of x will be known as basically the roots, its roots. Okay, solution of the equation. So ax square plus bx plus c is not equals to 0 is a quadratic polynomial. Ax square plus bx plus c equals to 0 is not equals to 0 is called a quadratic equation. What is a quadratic equation? When we put this with this equal sign and 0, we equate to the something. We are having something in RHS and LHS, then we'll know that this particular equation, this particular polynomial expression will convert into quadratic equation. Now, if this is a quadratic equation, this is a quadratic equation because we are having this equal sign, but this is what? A quadratic polynomial. Here, this is equation and this is also equation, quadratic equation. Now, this is an equation, but this is not a quadratic equation because it's not having its highest degree as 2. Okay, because the a is equals to 0 in this case. We are having something a x square minus 7x plus 2 equals to 0. When a equals to 0, that equation will reduce to minus 7x plus 2. That means the value of a is 0 here in this case. So this is an equation, but it's a linear equation, it's not a quadratic one. Okay. Now, solving quadratic equation by completing the square. Okay, after that we moved in that part, that how can we solve a quadratic equation by completing the square. X plus a, this is the format we have to deal with. X plus a whole square minus b square equals to 0, or x minus a whole square minus b square equals to 0. So we are basically reducing it in this form, square format. So this is known as solving a quadratic equation by completing the square. So the steps involved in bring, if required, all the terms of the quadratic equation to the left hand side. If there are some terms are written in this side and some terms are written this side other than 0, then you have to put all the terms in this side and equate it to the 0. X plus the term containing x as x square plus 2x or x square minus 2xy. Why? To complete the square, add and subtract y square. Now when you add and subtract y square, that will form x square plus 2xy plus y square. That will make the formula of x plus y whole square, or in the second case that will become x square minus 2xy plus of y square. That will again create x minus y whole square. That's completing a square. Okay, add and subtract y square to get this. Like this we are getting here. By adding, you are getting a complete square of x plus y square, either x plus y square or x minus y whole square, and you are left with this y minus y square, this situation or this situation. In the first case, when you will be having plus 2xy, be getting this one, and the second case we will be getting this particular format, we will be getting this one. You will be left with this one. Okay. These are the first 3 steps. Now, quadratic equation by using quadratic formula. Okay, or in this particular method, what you call it, Sridharacharya formula that we have studied. In this particular formula, you complete the perfect square as x square plus bx plus c. That will give us that we will divide this complete equation by this a. So that will convert into x square plus a by b, b by ax plus b by a equals to 0. When we add and subtract, that will be something like this, and the result will be ultimately given by x equals to minus b plus minus root of b square minus 4ac upon 2a. Okay, this will be the result. That means if I represent one root as alpha, now this is value of x and the value of x is what? Its root. So quadratic equation will have two roots. First is this one with the positive sign and second is this one with the negative sign. That means the positive sign will be this minus b plus root of b square minus 4ac upon 2a. This is with the positive sign that will be known as alpha, and the beta, the other root will be beta, and that will be minus b minus of root b square minus 4ac upon 2a. Now here this complete term b square minus 4ac, this complete term b square minus 4ac, we can cut it short with d, and this d will decide the nature of the roots. Okay, which we will study in later in this section. Okay, so complete it till there. Okay, so this Sridharacharya formula is very helpful in all the cases. We can solve any quadratic equation with this formula. Okay, and the quadratic equation is this, giving two roots alpha and beta. Okay, every quadratic equation has at most two and only two real roots. Okay, and only two real roots. Now nature or character, I've talked about this d that will decide what is d, b square minus 4ac, the particular number which is in the square root. Okay, that will decide. The nature of the root depend on the value of b square minus 4ac. This is called discriminant of the quadratic equation x square plus bx plus c equals to 0, and is generally denoted by d equals to this discriminant will be known as this d, b square minus 4ac. That can be equals to 0, less than 0 or more than 0. That can be equals to 0, less than 0 and more than 0. Now come this side, students. Here I have told you that b square minus 4ac equals to d. Now I am saying that d value may be 0, d value may be positive in case if the value is greater than 0. Okay, the last case is this may be negative. This implies that d will be less than 0. Okay, so this is in the root. This d is in the root. Okay, so if it's 0, so if we'll put this value as 0, so either it's minus b plus of 0 upon 2a, or it may be minus b minus of 0 upon 2a. In both the situations, when d equals to 0, in both the situations, the alpha and beta, the value of alpha and beta will be the same. That means there will be only one value of this equation. That means there will be only one and one root of this equation if d is equals to 0. Okay, this is the first thing. Now, two condition arises when this is positive. If this is positive, the value of d will be positive. If the value of d will be positive, okay, in that case, in this positive case, that can be a square, or that can be not a square. So if it's a square, so if this value is square of something, b square minus 4ac is a complete square of something like 16. If it's 16, then the value will come like 4. Okay, so that will be a rational number. In this case, that will be a rational number. If it's not, then that will be irrational number. Is it clear to you guys? Okay, if it's a complete square, then the value will be what? Then the value will be simply rational. If it's not, it will be irrational. but the value of d, if it's negative, then that will be imaginary. The roots will be imaginary if the value of d is negative. So its whole all depend on the value of d, that means b square minus 4ac. Okay, it's complete the game here. Okay, now it's written here, if d is more than 0, that b square minus 4ac, that means it's positive. The roots are real and unequal. Roots are real and unequal. If b square minus 4ac is a perfect square that we were talking about, the roots are rational and unequal. How the roots are? Rational and unequal too. Okay, I forgot this word. Rational, that will be rational but unequal also. In this case, second, if b square minus 4ac is positive but not perfect square, roots are irrational and unequal. What? Irrational but unequal. Now, in the both cases, these are real numbers. Okay. If d equals to 0, roots are real and equal. That means the value will be only 1 for alpha and for beta also, because root of b square minus 4 is equals to what? 0. Okay, and if d is negative, that means d is less than 0. In that case, that will be negative root. So roots will not be real. Roots will be imaginary. Roots will be imaginary. Okay. Now for now, you just only have to know that roots will be imaginary. We will not talk about this in what this imaginary roots are. Okay. That's beyond our syllabus right now. Hopefully in 11th you may know this. Okay, sum and products of root. I've told you sum and products of the roots. This is the sum of root and this is the product of the root. If we talk about alpha plus beta, when we sum these two roots, this plus this, what will be having? Minus b by a, that is minus of coefficient of x upon coefficient of x square, and in the multiplication we will be having c by a, constant term, and upon the coefficient of x square. Okay, this is the formula for summation and the product of roots. Okay, any confusion regarding this? I hope not. Next, to construct a quadratic equation whose roots are given. What we'll do, we'll use this. Okay, there will be 3 steps. First step will be finding alpha plus beta. In the second step, we'll be finding alpha multiplied by beta. Okay, and then we'll put this in this equation. X square minus alpha plus beta x plus alpha multiplied by beta equals to 0. And that will be your equation. That will be the equation. That will be the equation that you will be making from the given roots. Okay. So if the roots are given, you can make the equation by this formula. Okay. Note it. Now, equation reducible to the quadratic equation. There are some kind of equation. We will study 3 type of equation one by one. In type 1 we studied the equation of the form x4 plus bx square plus c equals to 0. What we did, we substitute x square as y. If we substitute this as x square as y, what this will become? A y square plus by plus c equals to 0. From this substitution, we can get the value of y. Okay, and by getting the value of y, we can just know the value of x, because y equals to what? X square. So by this we can have the value here. Okay, so the second method, equation of the form px plus qx equals to r. Okay, so in this format, what we will do, we will multiply each term by x. If we multiply these terms by x, that will become what? Px square plus q equals to rx. Now this will convert into this px square minus rx plus q equals to 0, which is again what format? X square plus bx plus c equals to 0. Now you know, we all know that how to solve this kind of equation. Okay. Sorry. the type 3 equation involving one radical like this. In this situation, what will you do? If you're seeing this kind of a square root, you'll just square it simply. Okay, square both the side to get this a minus x square is equals to bx plus c whole square. Now we'll be doing the simplification of this because it's only a linear term here, so that will also be converted into the square format. Here you are having a square, so in the end of this simplification, you will be getting again the format x square plus bx plus c equals to 0. And now you know how to deal with such kind of equation. Okay, so this is the pattern: the type 1, type 2 and the type 3 kind of equation. Now after that, we used these types for solving the quadratic equation. How we solve that? We have read the given statement of the problem carefully to find the required unknown quantity. Okay, in case you've given with some language question, what you have to do? You have to just read that question thoroughly, carefully also, and find out that what the examiner is asking. Take the unknown quantity as x. Okay, for the language question I am saying, unknown quantity will be taken as x, and according to the given statement, form an equation in term of x. In term of x, you will be having an equation. How will you form that? According to the statement. Simplify and solve the equation, get the value of x. And basically in this kind of question, that you will be getting an equation in square format. You will solve them. If it's making in the type 1, type 2 or type 3 format, you will be simplifying it. Okay, and will get the answer. So this was all about this chapter, quadratic equation. This is the brief summary. Now get back to your AriserTalent sheets and your textbook and do all the exercise question. Okay, we'll meet in next lecture with a damn new chapter. Okay students, take care. Bye bye.